let's do that, sure. You used to do the first one here. What did you use to do A? What's that called? You used the something that you use the integral, but there's a theorem. It's called it was the big theorem. Remember this? Yep, of calculus, yeah. So you use the fundamental theorem of calculus and you use the table, right? You had to take the table, so you did 5.2, which is right there. And then you had what else? 2, which is right there. So you're estimating, that estimate with that table of values is that the area under the curve is 3.2. That's the estimate. So how do you find the average value from 0 to 4? It's the integral times what? Remember you did this a bunch of times? 1 over b minus a. So wait, I just deleted that. I'm sorry. It's the integral from 0 to 4. But then this right here, what is this? That is 1 over b minus a. So this right here is what you figured out right there. The average rate of change from a to b of a function f of x is the integral of that function times 1 over it. You're trying to find the height of that box. Remember we did that before where like if you had a function and these are the values right here, you're trying to figure out this area and then you divide it by the base right here so that you can find what the average value is, which is you're effectively finding what is the rectangle that has the same area as that area under the curve. What is the area of that? What rectangle has a height that would give you the same area? That's what it is. Is it facing up or down? The parabola is facing down, so it goes like this, right? And this point right there, what's that point going to be? This is y equals negative x squared plus 4. So what's that highest point going to be? Yeah, it's going to be 0, 4, right? And what are these points going to be? These are kind of important too. What's that point going to be? 2, 0, and? Yes, so when they say point, make sure you say 2 numbers. It's okay, negative 2, 0, like that. Got it? So then you're trying to find the area between the function and the x-axis, right? So is pi greater than 2 or less than 2? Greater. Yeah, so you know that you're basically, this right here is going to be negative pi 0. And what's this one going to be right here? Pi 0, right? So what are you trying to find if you wanted to highlight this area? You're doing this, right? This plus what? You're doing this plus which areas? They look like triangles, but they're just really steep, right? Plus this, right? Now here's the thing, is area positive or negative? Is area positive or negative? Has to be positive, right? It has to be positive. So if you were to just do the integral, some of you might have, if you just set up, if I just said what's the integral from negative pi to pi? Negative pi to pi of negative x squared plus 4 dx. If I just said that, would that give you the area? No, what does that equal? That equals the what? The displacement, right? If you did this, what would you end up with? You'd end up with the purple minus the, blue. What do you want to end up with? Purple plus the blue. So what did we do for finding area? And this would be like distance traveled. You took the what? Absolute value. Yeah, so you do negative pi to pi of the absolute value of negative x squared plus 4 dx. At this point, what could you use to do this? What could you use? Yeah, you could use your calculator. Do that right now, everybody. Use your calculator right now and do fn int on this. So you're going to have y1 is equal to, you could say, I would do this, the absolute value of negative x squared plus 4. That's what I would do. And some of your calculators might have this instead. They might have the bars. Do some of you have the bars? And adds a little bit of thought process. It adds lag. Not that much because it's flipping everything. Remember, your calculator doesn't do calculus. Your calculator is not using the fundamental theorem of calculus here. It doesn't figure out the integral and then subtract. It does an estimate, and it just does the estimate really, 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 really close to the actual value. That's what it's doing here. Now, this is the answer. So if I wanted the answer to this, do that, and then I want at least 3 decimal places. So I would have expected 16.871. The thing is that the exact answer? No. Okay, so this is the question I want to answer, though, is how would we figure out the exact answer? You need to put the integrals together, a few integrals together. So what's the area for the purple region? Can someone tell me what the integral is for the area of the purple region? What integral would you do for the area of the purple region if you just wanted the purple? Yep. What is it?
You go from negative
2 to 2 of
negative x squared.
Yes, exactly. Now, is that an integral you could do? Yeah. Absolutely, right. You could do that one when I say do that, I mean by hand. You could do that by hand. Now, what about the blue regions? What can you tell me about the 2 blue regions, by the way? They are what? They're not triangles because it's a curve. It looks like a triangle, but that's the parabola right there. This side right there is curved, so it's not a triangle. That would be nice. That would be a good estimate, actually. It's not triangles. So what can you tell me? How do they compare to each other?
They're equal.
They're equal, right? So if we find 1, we have the Other. So I have a question, Connor. So if we want to do the blue one, we can't just do, why is this wrong? Why can't I do like 2 to pi of negative x squared plus 4? Because that would be a he's Connor, but yes, it's okay. That would be negative. If I were to integrate from 2 to pi, this would be negative, right? Because it's below the x-axis, but we want it to be what? Positive. So if we want to make it positive, what do you just do? You could do the absolute value, or what could you put on the outside? If something is negative and you want to make it positive, what do you multiply it by? So just put on a -1 on the outside. So you have two integrals right here, and then how many of those blue regions do you have? You have 2 of them, so what should we put on the outside? -2, exactly. So why don't you guys get to the board right now and any partners you want. So when you did it out, some of you might have gotten 32/3 for your first one. Who got 32/3? We've emphasized this before. What's the hardest part about doing these?
Plus C.
Well, you got to remember the plus C, but then when you're doing the algebra, be really careful. You could definitely get one like this, absolutely. So for this one, you're just plugging in similar amounts, but you're going to have pi in there. It's going to be a little bit harder. This one's going to be a little bit harder right here. So for this one right here, you just have to be more careful. You just have to be more careful. What do you think the most common single mathematical operation that's missed? What do you think the most common missed operation is on these? I'll give you a hint. Nope. The minus signs. Like miscounting minus signs, or like minus a minus is not a minus. Yeah, you can do that. Just to me, it's 16x to the 7th, right? And if I said, what's the integral of 16x to the 7th, you could go back and say it's 2x to the what? If I said the integral of 16x to the 7th, it would be?
16/8x.
Yeah, well, just go backwards. What is it? It's right there. You just did it, so it's going to be 2x to the 8th when it simplifies. So we can do that, but that's only polynomial functions. That's only polynomial functions. That's only, yeah, so x is up here in the top right here. X is up here in the top. Now, at this point, without learning anything else, the only way you could calculate one of these integrals or derivatives would be with your calculator. Can you type in the function 2 to the x in your calculator? Yes. So therefore, could you use fn int and n deriv? Yes, you could. The thing is, we need to know how to do this by hand as well. We need to know that. And what I'm going to give you is, I might just give it to you, but let's just try it out here. So let's say I said y is equal to 2 to the x. A question I could ask you would be, what is y prime? That would be the question we'd want to answer. What is the derivative of that? And one way we could do that is we could evaluate the derivative at certain values. Your calculator can't tell you what the function derivative is, but your calculator could tell you what's the derivative evaluated at 0. It can tell you what the derivative is evaluated at 1. It can tell you the derivative evaluated at 2, and it could tell you the derivative evaluated at 3. And then once you have those values, what could you try to figure out? A function. You could try to find a relationship. So you can use your calculator. Do you remember how to use your calculator to do derivatives? It's 2 to the x. So there's our function right there. Does anybody remember which one it is? It's math what? Where is it? 8. There's math 8. Okay, so I'm going to do d dx of, which function was it? y1, y vars, y1, and it's going to be at x equals what? What's the first one? 0. I do it x equals 0, and I press enter. It tells me the derivative is 0.693. Okay, 0.693. At first, I'm like, oh, dang it. That's not super nice, right? You're like, oh, dang it, that isn't super nice. But then we want to do second entry because it does the same thing. But then instead of x equals 0, what do I say? X equals 1. And what do I get? Oh, 1 point what? 1.386. Please do this for me. Fill in these two right here. Use your calculator. Yeah. Anybody else? Oh, someone else have the next one? Yeah, Liana, what is it? 545. So effectively, it's because what's easier? There's a definitive thing. Like you can't confuse what you're taking natural log of. So in this case, what is y prime evaluated at 2? That would be 2 squared times what? ln2. Do that on your calculator, and what do you get? 2 squared ln of 2. What do you get? 2.772. Oh, do we have that right there? Or 3 if you round it up. Yeah, it's right there. So what is that right there? That's going to be 2 to the 3rd ln what? 3. 2 to the third ln 3. So this right here is the nice present I want to give you, which is this is how you differentiate exponential functions. This is how you do it. Now you'll notice we haven't proven this. We haven't proven this. We don't have to prove it in this class. You get to use it. You just get to use it. We don't prove it in this class. Okay, so here's the next thing we have to figure out, which is not as hard as it looks, but what is it asking you for here? Is it asking you for the derivative? No. What is it asking you for, Jen, on this one? The what, though? Evaluate A. What does this symbol mean? Derivative of what is a to the x? That's the question it's asking. And what do we know has to be in it? A to the x has to be in it. But if we take the derivative of a to the x, what kicks out? What do we generate? ln a. So what do we need to put in front of this to get rid of the ln a? What do we need to put in front of this to get rid of the ln a? Okay, if I said, what did we do to find the integral of x cubed? It was x to the fourth, but what goes in front of it? 1 over 4, right? To get rid of that 4 power. So what goes in front of this one? 1 over not x, 1 over, nope. 1 over ln a. What is the derivative of a to the x? A to the x ln a. And what's it going to cancel with? The ln a, the 1 over ln a that's right there. So the derivative of this, and then so the integral is going to be plus c. So the answer to this is that. So what does that mean, just in terms of a specific example? Let's say I said, what is the integral of 2 to the x dx? What's the integral going to be of that? What's the integral of 2 to the x going to be? Based on that formula right there. 1 over ln 2 times what? Plus c. Done. That's it. So when you integrate, you have to put that 1 over thing in front of it. So let's do a couple examples in the nicest possible way. The nicest possible way. It doesn't look like it at first, but this is going to be one of your favorite numbers ever. I know you look at me skeptically right now, but it is absolutely going to be. Based on what you know right now, you see this here? The integral, that means the derivative of what is e to the x? Using the formula that we have right up there, it's up in the upper left. What's the integral of that going to be, Jen? What's the integral of this going to be? 1 over what? ln of e, right? Times what? Plus c. Can anybody tell me what ln e is? Do you remember what ln e is? Ln of e is just 1. Is just 1, right? So what does this whole thing equal? E to the x plus what? Done. This tells you that the integral of e to the x is what? E to the x. This is the only function you will see in a very long time, if not ever, that this is true for. What's the integral of e to the x? E to the x. What's the derivative of e to the x, do you think? Yeah, the derivative of e to the x is e to the x, because if you do the derivative of e to the x, that's equal to e to the x ln e. But what is ln e, Lizzie? 1. So what do you have here? E to the x. The derivative of e to the x is e to the x. It's a really interesting function. The derivative is itself, so therefore its integral is itself. Kind of cool. On b here, what number can we just factor out? We can factor out a 5 because it's a what? It's a constant. So does anything change here? Oh, it's just a 5 on the outside, so that's going to be e to the x plus c. So sometimes you might end up with math that looks like this. Do you know what the cool thing is you can do? Do you have to write it as 5c? No, you can just write it as, call it another letter, plus d if you wanted to. It doesn't matter. It's a constant. It doesn't matter. It doesn't matter what you call it. Okay, so get back to the board, everybody, in your pairs, and please do these two right here. 7, and it's 4 to the x dx. So it's going to be 7 times 1 over ln 4 times what? 4 to the x. So some people did this. Totally fine. Doesn't matter where you put the constant. It just has to be added at the end. That's it. It has to be added at the end. So some people might have finished with 7 over ln 4, 4 to the x, plus another letter. You can change the letter if you want. That's fine. Integrating, not differentiating. So you're right that it would be 1/3 x cubed. But what is the integral of pi squared? Pi squared x, correct, plus 1 over 5, sorry, 1 over ln 5, 5 to the x plus what? C. It's a constant. When you integrate, the x is going to pop up in there. It's going to pop up. means displacement, but that means you need to know what this looks like. This is what it looks like. This part right here is negative, and you're going all the way to what? 6? This is not to scale, of course. So this first part, oh yeah, the first part right there, the first part, 3 over ln 2. So that right there is a positive number, so that is a right there. You do the same thing for b now. You do the same thing for b, but you don't have to put a negative on the outside. The b is right here. That's the integral from what to what? 2 to 6 of the exact same thing. So Jen, when you were talking about the integral, you had integrated properly. You just didn't break it up. So you had the integral. Don't erase the integral. So you knew that the integral of this is going to be 1 over ln 2 times 2 to the x plus 4x. And this time you're just going from 2 to what? 6. Do you expect this to be a lot bigger? This is not drawn to scale. This goes way up, right? This goes really far up. So you expect this to be big, which it's going to be because you have 2 to the 6th right here. What do you end up with for an answer? You end up with 1 over ln 2 times 2 to the 6th plus 4 times 6 minus what? 1 over ln 2 times 2 to the what? 2 plus 4 times 2. So what's 2 to the 6th? That's 8 squared, which is? So you have 64 over ln 2 plus 24 minus 4 over ln 2 minus 8. So what does that simplify to? 60 over ln 2 plus what? Plus 16. So you have these two areas. So what do you have to do now? So we have negative 3 of them and 60 of them. So how many 1 over ln 2s do I have? So I take these and put them together, and I end up with 57 over ln 2. And then I have 16, plus what? 24. There's your final answer.